Good morning, everybody. Uh, Today is on December 1. I will this is our fourth tutorial regarding the demonstration of UMW implementation via using Omnet++ software. So previously we were explaining about different simple module and how it is implemented in C++. I have explained about application.ccc. Then I have explained routing.ccc. So today we will see another important simple module under a compound module. You know, our node is a compound module in which there is three simple modules have been defined. The app is there, routing module is there, and queue is there. The function of app is to generate a packet of a desired rate, in a desired rate. The function of routing is to either deliver the packet to its own node or to forward the packet to other node, like scheduling. Dynamic scheduling is implemented in routing, and the function of queue I will explain today. So before going into the C++ implementation, let's see what is what is inside the NAD file of a queue. What is the defined parameters are there. First parameter is the frame capacity. Is the capacity of the queue. It is finite capacity. I consider it to be finite, that there may be 1000 packets can be stored in a queue at a time, and if there is a packet which comes after 1000, then it will be dropped. Then the link capacity of the from one node to another node. Then there is some signals have been defined for statistical analysis purpose, like queue length, queuing time. A packet is inside the queue and how much it stay there. It is recorded in a queuing time. Then there is a drop, the number of packet which is dropped. You can see what are the unit of queue length is long, that is an integer value. Unit of queuing time is the simulation time in second, and the unit of drop is also a discrete quantity. It is a number. So what are the statistics we are going to record is like queue length. We want to record its time average value, max value, mean value. For queuing time, we wish to record the time average, max, mean. And for drop, we want to record the count and sum. The count is a number and sum is the total number of bytes. Okay. Now let's see what are the gates. Queue we have. There is a one input gate, one output gate, and one in-out gate. A gate which is named as a line. So how it is connected in the compound module, will be one input node that will come from routing output to input of queue in. You can see if we keep the cursor here in the link, you can see there will be a routing.in will go at the queue.i.out. Similarly, there will be an out gate from queue to routing there. Another is the in-out line for this to go to connect with the outside of the compound module, which is there. You can see there is a qi dot line. Is an in-out line is connected to the port I. That means this line is used to send the packets outside the compound module. Also, you can see that since it is a variable quantity, size of the port, the index of the queue, because in a simple module and in a compound module or node, we have a single app and single routing, but the number of queue depends on the number of link it is connected with the other node. Suppose that it is a node 1 and it is connected with the other 3 node 2, node 3, node 5. Then it will have 3 links, so the size of the queue will be 3. Okay, so it depends on how much what are the connection status of the network. If it is connected to only single node, then it will have only single link. So it depends on our final architecture, final network design. So now let's talk about how it is implemented and what are its functions. Like firstly, see what are the header files is defined. You can see there is some include libraries have been included, like Studio Edge, String Edge, Omnet++ Edge, algorithm, and then we have included 2 namespace, Omnet PP and standard library. Now since we have, I've already explained in previous lecture that since we have defined a queue NAD file, we have to make a class of the same name. You can see the name is the same, LTQE. Here is also the LTQE NAD, because Omnet++ must be aware that there is a NAD file, and that NAD file is registered with the Omnet++ through as class. So this class is defined which inherit publicly the C simple module class. So what are the content? Here is the private variable is there, the frame capacity, link capacity. Since we want to update our virtual queue, those time to update virtual queue, mean link weight. See, queue because queue is a container, so we have to define a class for the container. Then there is a message for defined, which is in transmission event. Is a bool function is busy, that means it will be 1 if the queue is currently busy, and it will be 0 when we can send the packet inside the queue, it will be 0. There are three, since we have defined the three statistics for recording purpose, so we have to register it using sim signal underscore t. So you can see that queue length signal, queuing time signal, drop signal. It is we have to define. Then there is one constructor and one destructor is there, and these are the four member function. First one is the initialize, that is called, that is invoked when we are first you initiate your simulation, you compile your code. Then there is a handle message. This member function is automatically invoked whenever this module will receive any packet from any node. Whenever a packet is received, this member function will be invoked. Then there are two functions, that is for firstly refresh display, because the simulation time we have to refresh our display to see the variation in the movement of the packets. And there is one start transmitting, this member function that has an argument of message. It will receive a message as an argument and do some processing. What they will do, I am going to explain. So now let's start with, we have to include our header file. Then using namespace omnet pp, you can see we have to register our class or NAD file with the Omnet++ by using this keyword define module. So now what is there is in constructor, like since we have defined a pointer, message pointer, so it is initialized with a null pointer, and then is at the destructor we have to cancel and delete this in transmission event. So in the initialize member function, time to update virtual queue is set to be 1 in second, like in every 1 second we wish to update our virtual queue, and the minimum link bit should be 1. That means when it is updated and like it is subtracted with the link capacity, it should not go minus, so its minimum value should be 1. Then we have to set the name of our container, which is queue, and we have to initiate a message in transmission event, because we know that our link is there is a finite transmission time to upload our data to the channel. So during that time, that in transmission event is taking care of that time, that when it is sent and it is invoked, at that time if a new packet comes to the queue, it will be stays there, and it will set the our bool function busy on. So in transmission event we create a new message whose name is in transmission event, and it is something which is I will explain in later. And then the frame capacity, we set the value of frame capacity from our simple module parameter, and the link capacity from the simple module modulator we assign a value. Then we have to register our 3 different types of signal with this register signal keyword, like queue length signal, because we have defined a you can see there is this defined queue length signal, queuing time signal, drop signal. So we have to register all of this signal in the C++ class. So is the here we have registered all the three signal. Then we initialize is busy to be false. So let's start with I will explain this later. First let's start with the handle message. What is happening there here is you can see one second. Whenever a packet is come, it will first check what is the packet. If packet is message equal to in transmission event, that means the message it is self message actually to update to check whether the transmission is on or off. So if it is equal to in transmission event, then it is called transmission finished, and is busy will be invoked to be false. That means now it is not busy. It is our queue is not busy. So first condition, it will check whether queue is empty or not. If it is empty, then there is no problem. Else if it is not empty, then firstly it will pop up this queue dot pop will take a message which is already stored in the queue and will store here in MSG, and it is to show output window like what is the queuing time. The queuing time is the simulation time at the current simulation time minus message time step when the message was first stated entered in the queue. So that difference represents the queuing time. So this queuing time will be registered with our signal. This one queuing time signal sim time minus message get time step, that means the queuing time. It is registered with the signal. Also at present, what is our queue length? Queue dot length is some will finite integer value. It will register with the QLN signal. Now it will send the message. It will call this function start transmitting message. So when a message this function is called, a message that message is will came here, and here it start it will output window it will show starting transmission of a message name. Okay, then at present time, since it is started the transmission, our queue will be busy. So is busy is invoked to be true. So now we have to check the what is the message length in bytes. So that is length is check and cast with the bytes, and that is represented by output that the byte length is in queue is num bytes. So this message will be now sent to send via send command to the line. In-out line is there, in-out line gate are there, so that message will be sent through in-out line output. $O represent the output because a line is a input both in-out line. So a single name with for both transmission. So we have to specifically mention whether it is output or input. So $in is there, then that means you are using the input line, and when it is $O, then it is represent the output line. So now we will check what is the in transmission time. That means depending upon our packet length, we will check how much time it will take to complete the transmission. So here it will be operated like it is sending through gate O, and we have to get the transmission channel and transmission finish time from here, and depending upon the duration we have to schedule a self message. Like schedule at, it is a command that is used to schedule a message for a particular time, and it is self message actually. So in transmission may suppose that there is a 0.5 second, that means it is 0.5 second will take to send the packet. Till then, after it will send that in transmission event message after 0.5 second. So again when it will send this line will be invoked. So this one has already explained. Now suppose that if a message has arrived through input line, suppose that from other node, if message arrived. So firstly it will check, it will send the message to the routing module. It will do nothing, it will send the message to the routing module. Else if the in transmission event is scheduled, and in between when the transmission event is scheduled but it is not received, and if the frame capacity and queue length is greater than equal to frame capacity, that means if the capacity of it is more than the capacity of the queue, then it will show this message that because it doesn't have the sufficient capacity, so it will receive the message but transmitter busy and queue is full, so discarding the message. And when the message is discarded, we have to record that the length of the discarded message by a drop signal. It will record the length of the message and we will delete the message. Otherwise, if the message is our queue is not full, then it will do what it will do. It will receive the message where currently transmission is busy, our transmission is going on, so it will give a timestamp when the message is arrived, and that message will now insert in the queue. It will take the message inside the queue, and the queue length will be recorded. Another condition maybe is that there is our queue is empty, there is no packet before, so it will at the output terminal it will give the value, it will show that received message, and since there is no delay or no queuing time, so it will emit the queuing time signal is simulation time 0. So it will again call this function starting message in order to send the message to other node. And this function is for representing our refreshing our display, because we are continuously sending packets and receiving packets. That transmission should be refreshed continuously, so this is for that purpose. So in this tutorial we have understood the functionality of queue, because queue is a module that will receive a packet from this own node or from other node. When it will receive the packet from their own node, from their own application, it will firstly check the status of the queue. If it is full, then we will discard the message. If it is not full but it is in a phase of transmission, as a particular packet is transmitting, so it will insert the packet inside the queue, and when the packet queue is empty, then it will send the message without any queuing delay to the other node. And when it receive a packet from other node which is destined to the particular node, then it will receive the packet and forward to the node via the output port. In the next lecture, I will explain about this network controller NED. This one, network controller NED is there, and I will explain how it is because UMW and the virtual queue updation is done here. So I will explain this in the next tutorial, in tutorial 5. So tutorial 5 will be our the last lecture for demonstration, and in tutorial 6 I will show how the complete network is working, and how the dynamic scheduling is happening, and how it is we can get an output, how we can get an output for different varying the different input parameters. Okay, thank you.